In today's lecture, we will begin by looking at the point-slope form of the equation of a line, which is in section 1.4. So we'll remember if what we had said that the slope equals what? The rise over the run, or the change in y over the change in x. How does this translate to the equation of a line? So let's say we have a line that's passing through these 2 points. And these 2 points, we'll call them, the coordinates of these points will be x, y, and then the coordinate at the other point x1, y1. So we can say that the slope is y minus y1 over x minus x1. Using the formula to find the slope, we can use it to be able to derive or come to the point slope form. So what we're going to do is, let me just rewrite this as y minus y1 over x minus x1. So what I'm going to do is I'm going to multiply both sides times x minus 1, x minus x1. Now you'll see that on the right hand side, the x's would cancel out, and I am now left with x minus x1 times m equals y minus, I forgot a 1 there, minus y1. Now what we want to do is, the actual notation is we usually have the y's on the left, so I'm going to rearrange this. I'm going to say y minus y1 equals x minus x1 times the slope, and I'm actually one last change over here, y minus y1 equals m times x minus x1. Because we're going to know the value of the slope, so we want to put m first, just so it looks a little bit nicer. And this is what we have, this is what we call the point slope form. Now, when do we use the point slope form? Just to make sure that I don't forget it, I'm going to write it here, equals m times x minus 1. So sometimes it is useful to use the point slope form when you're given 2 points that are passing through a line and you're asked to either leave it in point slope form or to write the slope intercept form of the equation of a line. So let's say you are given 2 points, and the points are 1, 7 and 3, 3. And you are asked to find the slope of the line first. Find the slope of the line, which is easy to do. The slope of the line. Now, simply to find the slope of the line, what you're going to do is you have to label one of your points as, let's say we'll call this one x, this one y, and this we'll call x1, y1. So, what we're going to do is we'll say that this is 3 minus 7 over 3 minus 1, which have 3 minus 7 is negative 4, and 3 minus 1 is 2, so your slope is negative 2. Now that you have slope equals to negative 2, what we're going to do is we are going to use the point slope form to be able to come up with the slope intercept form. So recall that we have y minus y1 equals m times x minus 1. So I am going to substitute for y1, and I'm going to substitute for x1 and for m. So going back to the equation, so I have y minus 3 equals negative 2 times x minus 3. And I'm going to solve for y. So on the left hand side, I'm still going to have y minus 3. On the right hand side, I'm going to use the distributive property. So I have negative 2x plus 6. Now I add 3 to both sides. And the equation of my line is y equals negative 2x plus 9. Notice that in this case, we chose to use the point 3, the coordinate points. Now we can also use the point 1, 7, the coordinate point, and you will come up with the exact same equation of the line, the intercept form. So let's try it out. So now I have y minus 7 equals, the slope does not change, therefore we can just write negative 2 times x minus 1. We solve for y to find the slope-intercept form, so we have y minus 7 equals negative 2x plus 2. We add 7 to both sides, and we have y equals to negative 2x plus 9. Either point gives us the exact same slope-to-intercept form, and that's the way that it should be. So a lot of the times when you use the point-slope equation of the line, you either will going to be given 2 points, you will find the slope, and then from the slope you can plug it into the point-slope form and come and do some manipulations of the math to be able to come up with the slope-intercept form.